Hi friends, welcome to something called science.com. Today we'll talk about the fascinating topic of anions and cations. You might have heard the terms before, but what exactly are anions and cations and why are they important? Let's break it down. So let's define what anions and cations are. Anions are negatively charged ions, while cations are positively charged ions. Remember, an ion is an atom or a molecule that has a net electric charge. How does this happen? Well, all atoms have both protons and electrons. Protons are positively charged particles, while electrons are negatively charged particles. If an atom has more electrons than protons, it has a net negative electric charge. In this case, the ion is an anion. If the atom has more protons than electrons, it has a net positive electric charge. In that case, the ion is a cation. In other words, if the net electric charge of an ion is negative, the ion is an anion. On the other hand, if the net electric charge of an ion is positive, the ion is a cation. So what happens to create anions and cations? Suppose we have an atom with the exact same number of protons and electrons. This means that this atom has no net electric charge, because the number of protons and the number of electrons cancel each other out. Now, when this atom gains extra electrons, it becomes negatively charged, because it now has more negatively charged electrons than positively charged protons. For example, if an atom has 6 protons and 6 electrons, it is neutral. If it gains an extra electron, it now has 6 protons and 7 electrons. This gives it a net charge of -1, making it an anion. On the other hand, if that same atom with 6 protons and 6 electrons loses an electron, it now has 6 protons and 5 electrons. This gives it a net positive charge of +1, making it a cation. Let's look at some examples of anions and cations. One example of an anion is a chloride ion. When a chlorine atom gains an electron, it becomes a chloride ion. Chlorine has 17 protons and 17 electrons. Now, when it gains 1 electron, it has 18 electrons, resulting in a -1 net charge. This makes it an anion. Another example of an anion is a sulfide ion. When a sulfur atom gains 2 electrons, it becomes a sulfide ion. Sulfur has 16 protons and 16 electrons. When it gains 2 electrons, it has 18 electrons, resulting in a -2 net charge. This makes it an anion. Now let's look at two examples of cations. The first example of a cation is a sodium ion. When a sodium atom loses an electron, it becomes a sodium ion. Sodium has 11 protons and 11 electrons. When it loses 1 electron, it has 10 electrons, resulting in a +1 net charge. This makes it a cation. Another example of a cation is a calcium ion. When a calcium atom loses 2 electrons, it becomes a calcium ion. Calcium has 20 protons and 20 electrons. When it loses 2 electrons, it has 18 electrons, resulting in a +2 net charge. This makes it a cation. So how do anions and cations actually form? The process typically occurs during chemical reactions. Such chemical reactions can happen when you put 2 or more different elements together. It depends a bit on the chemical reaction that you're looking for, but the conditions under which you put these elements together matter. For example, some chemical reactions need heat or light to happen, whereas others don't. An example of a chemical reaction that does not require heat or light to happen is the creation of table salt. Let's break down the process of making table salt to show how anions and cations form. To make table salt, you need 2 main ingredients, sodium and chlorine. Sodium is a shiny soft metal that has 11 protons and 11 electrons. Chlorine is a greenish-yellow gas that can be quite dangerous on its own. As mentioned, chlorine has 17 protons and 17 electrons. When sodium and chlorine come together, they undergo a chemical reaction. This means they interact in a way that changes their properties and forms a new substance, namely table salt. So what is the role of sodium in this? Well, sodium has one extra electron that it doesn't need. What I mean by that is that sodium happens to have one electron in its outermost shell, which is its third shell, and this electron actually makes it unstable. This is the case because atoms are most stable when their outermost electron shell is full. For many elements, this means having 8 electrons in the outermost shell. Since sodium has only one electron in its outermost shell, it is not stable, and because atoms prefer to be stable, it kind of wants to lose that electron so that it becomes more stable. Because sodium is eager to lose that extra electron, it reacts readily with other elements, for example with chlorine. Now what happens when sodium meets chlorine is that sodium gives away that extra electron. And it does that because chlorine really wants that electron. Now let's turn to the role of chlorine in the formation of table salt. Why does chlorine really want that electron? Well, chlorine has 7 electrons in its outermost shell, so it's just 1 electron short of having a full outermost shell with 8 electrons. When it gets the electron from sodium, it becomes negatively charged because it now has more electrons than protons, the positively charged particles in its nucleus. This transfer of an electron allows sodium to achieve a stable electron configuration, while chlorine achieves a full outer shell. After this exchange of electrons, sodium becomes a positively charged ion because it has lost an electron, and chlorine becomes a negatively charged ion because it has gained that electron. These positively and negatively charged ions are attracted to each other because opposite charges attract. They form an ionic bond and stick together to form a stable compound, namely sodium chloride, which is table salt, also known as NaCl. The end product is a white crystalline substance that we know as table salt. It's safe to eat and is used in cooking and food preservation. In summary, making table salt involves sodium giving away an electron to chlorine and then coming together to form a new stable substance. This simple reaction is a great example of how elements can combine to create something completely different. There are two final things to know about anions and cations. The first is that metals tend to lose electrons and become cations, while nonmetals gain those electrons to become anions. Going back to our example with the table salt, sodium, which becomes a positively charged ion, so a cation, is classified as a metal. Chlorine, on the other hand, is a nonmetal and gains the electron to become an anion when it interacts with sodium. In summary, an anion is a negatively charged ion formed when an atom gains one or more electrons. This extra negative charge comes from having more electrons than protons. On the other hand, a cation is a positively charged ion formed when an atom loses one or more electrons. This extra positive charge comes from having more protons than electrons. Anions and cations are essential in various chemical reactions and biological functions, making them a fundamental part of the world around us. If you found this video helpful, don't forget to like, subscribe and hit the notification bell for more science content. It really helps the channel out. Let us know in the comments if you have any questions or topics you'd like us to cover next. Thanks for watching and see you in the next video.